September 12, 1944, near Arrogance, France. SS Oberscharführer Ernst Bachmann stood in the commander's cupola of his Panther tank, surveying the rolling French countryside with the confidence of a veteran who had survived 2 years on the Eastern Front. Behind him, distributed across the gentle hills, sat 12 more Panthers and 3 Tiger the Fan heavy tanks from the 2nd Panzer Division. German armored doctrine had positioned them perfectly. They occupied commanding terrain with clear fields of fire extending 2,000 meters. Any American Sherman attempting to advance would be destroyed long before it could return effective fire. Bachmann's confidence was rooted in mathematical certainty that had governed tank warfare since 1942. His Panther's frontal armor, 80 millimeters thick at 55 degrees, provided effective protection equivalent to 140 millimeters of vertical armor. The American Sherman's standard 75 millimeter M3 gun couldn't penetrate this armor at any combat range. Even the newer 76 millimeter M1 gun, which intelligence reported some Shermans now carried, could only penetrate Panther frontal armor at ranges under 500 meters with perfect shot placement. The Tigers behind him were even more invulnerable, with 100 millimeters of frontal armor. German tank commanders had learned to trust their armor absolutely. It was the foundation upon which all tactics were built. At 14:20 hours, Bachmann spotted movement in the valley below. American Shermans, approximately 15 vehicles advancing in 2 columns. Through his binoculars, he noted several were the newer M4A3 variants with 76 millimeter guns, identifiable by their longer barrels and muzzle brakes. He calculated engagement ranges. The lead Shermans were at 1,800 meters, well beyond their effective range, but within perfect killing distance for German guns. He ordered his gunner to target the lead Sherman. The Panther's 75 millimeter KWK-42 L70 gun, one of the finest tank weapons in the world, could penetrate any Sherman at this range. Before Bachmann could give the order to fire, the world exploded. His Panther shuddered violently, a massive impact against the frontal glacis plate that rang through the hull like a cathedral bell. Impossible. They were outside American gun range. Bachmann's driver reported no penetration, but the psychological impact was profound. Shermans didn't shoot at Panthers from 1,800 meters because it was pointless. Yet another impact struck, this time against the turret front. The tungsten carbide core of the M93 hypervelocity armor-piercing round punched through 80 millimeters of sloped armor as if it were sheet metal, killing Bachmann's loader instantly and setting off ammunition in the ready rack. As Bachmann abandoned his burning Panther, watching his crew evacuate through smoke and flames, he witnessed something that shattered 2 years of armor combat experience. The 3 Tigers behind his position, the invincible heavy tanks that no Allied weapon should penetrate frontally, were burning. All 3. Destroyed in less than 3 minutes from ranges that German doctrine said were completely safe. The Americans advancing through the valley weren't using standard ammunition. They had deployed something new, something German intelligence had failed to detect, and it had just rendered German armor superiority meaningless. What Bachmann and his fellow tank commanders didn't know was that the Americans had solved the armor penetration problem through metallurgy innovation rather than larger guns. High-velocity armor-piercing ammunition, utilizing tungsten carbide cores and reduced diameter projectiles, could punch through German heavy tank armor from ranges German crews thought provided absolute safety. Within days, reports would flood into German headquarters from all across the front. Tigers being destroyed at 1,500 meters. Panthers penetrated from angles previously considered immune. The mathematical certainty that had governed armored warfare was being rewritten, and German tank crews were learning the new equations written in tungsten and defeat. The story of how German armor invincibility died at Arrogance begins not with tanks, but with American industrial chemistry and a critical strategic resource most people had never heard of: Tungsten, element 74 on the periodic table, possessed properties that made it invaluable for armor-piercing ammunition. With a density of 19.3 grams per cubic centimeter, nearly twice that of lead, tungsten could concentrate enormous kinetic energy in a small projectile. Its melting point of 3,422 degrees Celsius meant it remained solid during the friction and heat of armor penetration. Most importantly, tungsten carbide, when properly processed, maintained structural integrity even when striking hardened steel armor at velocities exceeding 3,000 feet per second. The United States controlled approximately 90% of the Western Hemisphere's tungsten supply through mines in Colorado, Nevada, and California. American production reached 10,000 tons annually by 1943, more than enough to supply both armor-piercing ammunition and machine tool production. Germany, by contrast, had limited access to tungsten after 1942. Their primary source, Portuguese mines, provided only 3,500 tons annually, and Allied intelligence operations systematically disrupted even this limited supply. By 1944, German tungsten-cored ammunition production had virtually ceased. The Panzer Granate 40, their tungsten-cored anti-tank round, was so rare that most tank crews never saw one. This disparity in strategic materials would prove decisive in the armor battle. The development of American hypervelocity armor-piercing ammunition began in 1943, when Ordnance Department engineers confronted an uncomfortable reality. The standard 76mm M62 armor-piercing round couldn't reliably penetrate German heavy tank armor at combat ranges. The M62, a conventional full-caliber projectile, left the gun barrel at 2,600 feet per second. At 1,000 meters, it could penetrate approximately 90 millimeters of armor. This was insufficient against Panthers with effective frontal protection of 140 millimeters, and completely inadequate against Tigers with 100 millimeters of vertical armor or King Tigers with 150 millimeters. American engineers adopted a radical solution, the sub-caliber projectile. The M93 HVAP round consisted of a tungsten carbide core, 41 millimeters in diameter, encased in an aluminum sabot that fell away after leaving the barrel. The reduced diameter projectile, launched at 3,400 feet per second, concentrated enormous kinetic energy on a small impact point. The physics were devastating. Kinetic energy equals 1/2 mass times velocity squared. By increasing velocity by 30% while reducing frontal area by 50%, the M93 achieved penetration values that approached those of guns twice its caliber. The technical specifications of the M93 HVAP round revealed American engineering excellence applied to a critical military problem. The complete round weighed 15.4 pounds, slightly more than the standard M62. The tungsten carbide penetrator weighed 4.1 pounds, containing 3.8 pounds of pure tungsten. The aluminum sabot, designed to separate cleanly at approximately 100 feet from the muzzle, weighed 2.3 pounds. The propellant charge was increased by 18% over standard ammunition, generating higher chamber pressures that required careful metallurgical attention to gun barrel strength. The result was a projectile that could penetrate 150 millimeters of armor at 1,000 meters, compared to 90 millimeters for standard ammunition, a 67% increase in penetration power. Production of HVAP ammunition began in earnest in June 1944, though initial quantities were limited by tungsten availability and manufacturing complexity. The Frankfurt Arsenal in Philadelphia produced the tungsten cores using powder metallurgy techniques. Pure tungsten powder was mixed with carbon, compressed under pressures exceeding 50,000 pounds per square inch, then sintered at 2,800 degrees Fahrenheit in hydrogen atmospheres. The resulting tungsten carbide cores were then machined to precise tolerances, ground to final dimensions within 0.001 inches, and inspected for internal flaws using X-ray equipment. Each core required approximately 40 hours of production time from raw tungsten to finished component. The aluminum sabots were manufactured by Reynolds Metals using proprietary extrusion techniques. The sabot had to separate cleanly without damaging the penetrator or affecting its ballistic trajectory. This required precise balancing and carefully engineered separation joints that would fracture at exactly the right moment under exactly the right forces. Early production batches showed inconsistent accuracy until engineers refined the sabot design. By August 1944, rejection rates had dropped to less than 2%, and HVAP rounds were achieving accuracy comparable to standard ammunition. German intelligence first noted unusual armor penetrations in July 1944 during Operation Cobra, after action reports from the 2nd SS Panzer Division Das Reich mentioned Panthers destroyed by frontal hits at ranges exceeding 1,200 meters. The damage patterns were unusual. Instead of the large irregular holes typical of 75 mm or 76 mm penetrations, these were small, perfectly circular punctures, approximately 40 mm in diameter. The metal around the penetration showed extreme deformation, characteristic of very high velocity impacts. German metallurgists examining damaged armor plates couldn't explain how a 76 mm gun could produce such effects. Initial German assessments attributed these penetrations to the American 90 mm gun mounted on M36 tank destroyers. This explanation was comforting because it suggested Germans had merely encountered a new vehicle type, not a new ammunition type. The 90 mm gun was known to be formidable, and German doctrine already included procedures for dealing with tank destroyers. But reports continued to arrive describing Sherman tanks, clearly identifiable as standard M4 variants, achieving penetrations at ranges that should have been impossible. By August, German intelligence was forced to conclude that the Americans had deployed a new ammunition type with significantly enhanced penetration capabilities. The Battle of Arrogance, September 19 to 29, 1944, provided the most comprehensive demonstration of HVAP effectiveness against German armor. The 4th Armored Division, equipped with M4A3 Shermans, mounting 76 mm guns, and supplied with limited quantities of M93 HVAP ammunition, faced the 5th Panzer Army's best units, including the 111th and 113th Panzer Brigades. These German formations included 86 Panthers and 14 Tiger IIs, representing the most modern and heavily armored vehicles in the Wehrmacht inventory. German commanders approached the battle with confidence based on 2 years of armor combat experience where German tanks had consistently outmatched Allied armor. On September 19th, the opening engagement shattered German expectations. Company A of the 37th Tank Battalion, equipped with 12 Shermans, engaged 16 Panthers at ranges between 1,200 and 1,800 meters. Using HVAP ammunition for their opening salvos, the Americans destroyed 7 Panthers in the first 5 minutes. German return fire was ineffective at these ranges against the hull-down American positions. The German tank commanders couldn't comprehend what was happening. Their Panthers were being frontally penetrated at ranges where German doctrine said they were invulnerable. The psychological impact was immediate and devastating. Lieutenant Colonel Creighton Abrams, commanding the 37th Tank Battalion, described the engagement in his after-action report. The new HVAP rounds performed beyond expectations. We engaged Panthers at ranges where they thought they had advantage. The tungsten penetrators punched through their frontal armor like paper. Several German tanks were destroyed before they could return fire. The few that did engage us couldn't penetrate our hold-down positions at range. The Germans appeared confused and demoralized by their losses. Over the 10-day Battle of Arrogance, the 4th Armored Division destroyed 281 German armored vehicles, including 86 Panthers and 7 Tiger IIs, while losing only 48 Shermans. This 5.9 to 1 kill ratio reversed every previous battle's outcomes. American tank crews who had learned to fear German armor superiority now hunted Panthers and Tigers with confidence. The transformation was entirely attributable to HVAP ammunition. Tank for tank, the Sherman remained inferior to German designs in armor and gunpowder, but armed with HVAP, the Sherman could kill Panthers and Tigers from ranges where German crews had thought themselves safe. German tank commanders who survived Arrogance carried home reports that shocked the Panzer High Command. Hauptmann Franz Josef Strauss, commanding a company of Panthers in the 111th Panzer Brigade, wrote in his combat report, "The enemy has deployed ammunition that penetrates our frontal armor at ranges exceeding 1,500 meters. 3 of my Panthers were destroyed in the first engagement before we could identify the source of fire. The Americans appear to have solved the armor penetration problem without deploying heavier guns. Our armor advantage has been negated." The psychological impact of HVAP on German tank crews cannot be overstated. For 2 years, German tankers had relied on their armor superiority as both tactical advantage and psychological comfort. They knew that in most engagements, they could destroy Allied tanks before those tanks could hurt them. This knowledge provided courage in combat and confidence in survival. HVAP destroyed both. Now every engagement carried the possibility of death from ranges previously considered safe. German tank commanders became cautious, hesitant to expose themselves, slower to maneuver. This psychological paralysis proved as devastating as the physical destruction HVAP inflicted. The distribution of HVAP ammunition revealed American logistical priorities and industrial capacity. Initial production in June 1944 yielded approximately 10,000 rounds, a minuscule quantity compared to standard ammunition production of 2 million rounds monthly. The Ordnance Department allocated HVAP to specific units based on strategic importance. 1st Armored Division received 500 rounds. 3rd Armored Division got 400 rounds. The 4th Armored Division, preparing for the Arrogance operation, received 1,200 rounds. Even these limited quantities proved decisive because commanders used HVAP selectively, reserving it for engagements where its unique capabilities were essential. Tank commanders developed tactical doctrine around HVAP's strengths and limitations. The rounds were expensive, costing approximately $45 each compared to $8 for standard AP rounds. They were scarce, with resupply uncertain. They were also slightly less accurate than standard ammunition at extreme ranges due to the separation dynamics. Doctrine therefore emphasized using HVAP for the opening shots against German heavy armor, then switching to standard ammunition once penetration was achieved or if targets of opportunity appeared. This selective use multiplied HVAP's effectiveness, ensuring tungsten rounds were employed where they provided maximum advantage. By October 1944, HVAP production had increased to 50,000 rounds monthly as more tungsten became available and manufacturing processes were refined. The Frankfurt Arsenal added a second production line. Reynolds Metals opened a dedicated sabot factory in Richmond, Virginia. The Radford Ordnance Works in Virginia began producing propellant specifically optimized for HVAP's higher pressure requirements. This industrial mobilization reflected American capacity to identify a critical need and rapidly scale production to meet it. German tungsten shortages meant they couldn't respond with their own improved ammunition, even if they had recognized the solution. The effectiveness of HVAP extended beyond the 76mm gun. The M190mm gun, mounted on M36 tank destroyers and M26 Pershing heavy tanks, also received HVAP ammunition designated T30E16. This round, with its larger tungsten core and higher velocity, could penetrate 190mm of armor at 1,000 meters, making it effective against even the King Tiger's 150mm frontal armor. The 3-inch gun mounted on M10 tank destroyers received the T4 HVAP round, giving these older vehicles renewed effectiveness against German armor. American ordnance engineers had systematically equipped their entire anti-tank arsenal with tungsten penetrators. German attempts to counter HVAP focused on tactical rather than material solutions because they lacked the tungsten to develop equivalent ammunition. Field Marshal Walter Model issued tactical directives in October 1944, instructing panzer commanders to avoid long-range engagements where HVAP advantages were greatest. German tanks were ordered to close rapidly to under 800 meters, where their superior armor thickness and gunpowder still provided advantage. This tactical adjustment effectively surrendered the long-range engagement advantage that had been fundamental to German armor doctrine since 1941. The new tactics created their own problems. Closing to 800 meters meant German tanks had to cross open ground where they were vulnerable to American artillery, air attack, and flanking fire. The rushed approaches disrupted German coordination, preventing the methodical, synchronized attacks that had characterized successful panzer operations. American commanders quickly recognized that German armor was behaving atypically, charging forward rather than engaging from prepared positions. They adjusted their own tactics to exploit this, using HVAP-equipped Shermans to force German tanks into movements that exposed them to artillery and airstrikes. By November 1944, HVAP had fundamentally altered the armor balance on the Western Front. American tank battalions equipped with 76mm guns and supplied with HVAP could engage German heavy armor on equal terms. The Sherman remained inferior to the Panther in mobility and armor, and inferior to the Tiger in armor and gunpowder. But HVAP meant that American crews could kill German tanks from positions of concealment before German tanks could bring their superior characteristics to bear. The engagement at Arrogance had demonstrated this decisively, and subsequent battles confirmed the lesson. The Battle of the Bulge in December 1944 provided another test of HVAP effectiveness, though under different conditions. German forces achieved tactical surprise, initially catching American units unprepared. In the confused fighting through the Ardennes forest, engagements occurred at close range where HVAP's advantages were less pronounced. Nevertheless, American tank destroyers and Shermans equipped with HVAP played crucial roles in stopping German armored spearheads. At St. Vith, M10 tank destroyers using HVAP destroyed multiple Panthers and Tigers at ranges under 1,000 meters, contributing to the defense that delayed German advance. Staff Sergeant Paul Volkmann of the 814th Tank Destroyer Battalion described engaging Tigers near St. Vith. "We were positioned hull down behind a ridge when 3 Tigers appeared at about 800 meters. We fired HVAP from our M10s. The first round penetrated the lead Tiger's turret front. The crew bailed out immediately. The second Tiger tried to reverse, but we hit it in the gun mantlet. It caught fire. The third Tiger got off 2 shots before we killed it. All 3 Tigers destroyed in less than 2 minutes. The HVAP made all the difference." German tank crews captured during the Bulge offensive consistently cited HVAP as a primary concern in interrogations. Oberscharführer Fritz Langanke, captured when his Panther was disabled near Bastogne, told interrogators, "We knew the Americans had special ammunition that could penetrate our frontal armor. Every engagement carried the fear of this ammunition. We couldn't tell which Shermans carried it until they fired. By then, it was too late. The psychological effect was devastating. We had lost our armor advantage, which had been our primary source of confidence." The production statistics for HVAP ammunition through the war's final months demonstrated American industrial capacity scaling to meet battlefield demands. December 1944, production reached 75,000 rounds as the Battle of the Bulge demonstrated the need for more tungsten ammunition. January 1945, production hit 100,000 rounds monthly. February saw 120,000 rounds delivered to European forces. By war's end, over 800,000 M93 HVAP rounds had been manufactured, along with 150,000 T30 E16 rounds for 90mm guns and 80,000 T4 rounds for 3-inch guns. Total tungsten consumption for armor-piercing ammunition exceeded 3,000 tons, demonstrating American willingness to devote strategic resources to solving tactical problems. The effectiveness statistics compiled from after-action reports revealed HVAP's impact. At ranges exceeding 1,200 meters, HVAP-equipped 76mm Shermans achieved a 73% first-round hit rate against Panthers compared to 31% for standard AP ammunition. Penetration probability at 1,200 meters was 89% with HVAP versus 12% with standard AP. These dramatic improvements transformed the 76mm gun from marginally effective to reliably lethal against German heavy armor. Tank crews who had felt outmatched suddenly possessed confidence in their weapon systems. By March 1945, German armored forces were collapsing not just from fuel shortages and numerical inferiority, but from psychological defeat. Tank crews who had once maneuvered aggressively now hesitated, knowing that American tanks could kill them from ranges they had thought safe. The mathematical certainty that had governed armored warfare since 1942 had been overthrown by American metallurgy and industrial capacity. Every engagement carried the possibility of death from HVAP rounds that punched through supposedly invincible armor. The final battles in Germany saw HVAP used extensively as American forces encountered dug-in German tanks used as static pillboxes. At the Remagen bridgehead, HVAP-equipped tank destroyers systematically destroyed Panthers positioned to defend the Rhine crossing. In the Ruhr pocket, Sherman tanks used HVAP to engage German armor at long range, minimizing American casualties while maximizing German losses. The cumulative effect was systematic destruction of remaining German armor, without the close-range slugfests that had characterized earlier fighting. German tank commanders who survived encounters with HVAP carried their experiences like psychological wounds. The transformation from confidence to fear occurred not gradually, but in single moments of comprehension when supposedly invincible armor failed. Oberleutnant Hans von Rosen, commanding a Tiger the Fund Company, in the 501st Heavy Panzer Battalion, experienced this transformation on October 3, 1944, near Metz. His after-action report, discovered in captured German documents, provided insight into the psychological collapse HVAP inflicted. Von Rosen had positioned his Tigers on high ground overlooking American approach routes, a textbook defensive position that maximized German advantages. 3 Tigers, 100mm of frontal armor, 88mm guns that could destroy any Allied tank at 2,500 meters. The Americans would have to advance uphill across open ground. Von Rosen calculated they would destroy at least 10 Shermans before the Americans could close to effective range. The mathematics seemed certain. Then the first HVAP round struck his lead Tiger's turret front at 1,400 meters, penetrating completely and detonating the ammunition storage. The Tiger's turret lifted off its ring and crashed back down at an angle, a catastrophic kill that left no survivors. Von Rosen's report captured the moment of realization. The American round penetrated Oberscharführer Dietrich's Tiger from the front at a range where this should be impossible. The penetration was clean, a small hole indicating very high velocity impact. This was not the 75mm gun we had faced previously. Either they have deployed a new tank with a much larger gun, or they have developed ammunition we didn't know existed. Both possibilities are equally disturbing. If they can kill Tigers frontally at 1,400 meters, our entire tactical doctrine is invalidated. The second possibility proved correct, and von Rosen's tactical doctrine did indeed collapse. Within a week, his unit had lost 7 Tigers. 5 penetrated frontally at ranges exceeding 1,200 meters. German armor superiority, the foundation of panzer effectiveness since 1941, had evaporated. Von Rosen's final report before being relieved of command stated bluntly, "We cannot win engagements against American armor equipped with this new ammunition. Our men's morale is destroyed. They no longer trust their armor to protect them. The individual stories of tank crews destroyed by HVAP revealed the human cost of technological surprise. Unteroffizier Werner Müller, a Panther loader who survived when HVAP killed his commander and gunner, described the experience in a 1983 interview. "The American round came through the turret front. I heard it hit, a sound like a hammer striking an anvil, then everything exploded. The penetrator punched through our armor as if it wasn't there, hit the ready ammunition, and the whole turret filled with fire and shrapnel. Our commander died instantly. The gunner lived long enough to scream. I escaped through the floor hatch with burns covering 40% of my body." Müller's account continued. "What I remember most wasn't the pain, but the impossibility of it. We had been hit from the front at over 1,000 meters. That couldn't happen to a Panther. German doctrine said it couldn't happen. Our training said it couldn't happen. But it did happen, and 2 of my friends died because our superiors didn't know the Americans had developed ammunition that made our armor worthless. After that day, I never felt safe in a tank again. Every engagement was terror that another impossible penetration would kill me." The psychological transformation HVAP inflicted spread through German armored units like a contagion. Tank crews who had operated with confidence now flinched at every incoming round. Commanders who had maneuvered aggressively now hesitated, worrying that any American tank might carry the deadly tungsten ammunition. This fear affected combat performance measurably. German after-action reports from November 1944 noted increased reaction times, conservative maneuvering, and reluctance to engage American armor even when tactical situation favored Germany. General der Panzertruppen Hasso von Manteuffel, commanding the 5th Panzer Army, recognized the psychological crisis and attempted to address it through training and tactical adjustments. In a November 1944 directive to subordinate commanders, he wrote, "Reports indicate our tank crews have lost confidence in their armor protection due to American ammunition capable of penetrating our heaviest tanks at long range. This psychological problem is as dangerous as the technical problem. Commanders must restore crew confidence through emphasis on tactics that negate American advantages. Avoid long-range engagements. Close rapidly to under 800 meters, where our armor thickness and gun power still provide advantage. Use terrain aggressively to prevent American tanks from achieving firing positions." Von Manteuffel's directive revealed clear understanding of the problem, but offered no real solution. The tactics he prescribed surrendered the long-range advantage that had been central to German armor doctrine. They required German tanks to maneuver aggressively across open ground, where they were vulnerable to American artillery and air attack. Most critically, they assumed German crews could overcome their fear and execute aggressive tactics when every engagement carried the possibility of death from ammunition they couldn't defend against. The psychological damage HVAP had inflicted proved more difficult to repair than damaged armor. American tankers, by contrast, experienced a psychological transformation in the opposite direction. Crews who had learned to fear German armor through bitter experience in Normandy now hunted Panthers and Tigers with confidence. Staff Sergeant Lafayette Poole, commanding a Sherman in the 3rd Armored Division, described the change. "When we first got HVAP, nobody believed it would work. We'd been fighting Panthers and Tigers for months, watching our shells bounce off while they killed us at ranges we couldn't touch them. But the first time I used HVAP against a Panther at 1,300 yards and watched it brew up, everything changed. We weren't helpless anymore. We had a weapon that could kill them. That knowledge made all the difference." Poole's combat record illustrated HVAP's impact. Between August and December 1944, he destroyed 12 German tanks, 9 Panthers, and 3 Tigers, all at ranges exceeding 1,000 meters. All but 2 kills were achieved using HVAP ammunition. His gunner, Corporal Wilbert Richards, achieved a 91% first-round hit rate with HVAP, compared to 34% with standard ammunition, demonstrating how the tungsten round's flat trajectory and velocity improved accuracy at long range. Poole and Richards represented hundreds of American tank crews whose effectiveness multiplied when armed with ammunition that negated German armor advantages. The technical analysis of HVAP penetrations revealed why the ammunition was so devastating against German armor. When a tungsten carbide penetrator struck armor at 3,400 feet per second, the kinetic energy concentrated on the small impact point exceeded the armor's ability to distribute the force. The armor plate deformed locally, creating a plug that the penetrator pushed through the plate. Behind the armor, the plug and penetrator fragments created a cone of destruction that killed crew members, destroyed equipment, and often ignited ammunition or fuel. The small entry hole, typically 41 millimeters in diameter, belied the catastrophic damage inside the tank. German metallurgists examining HVAP-damaged armor plates identified the tungsten carbide composition, but couldn't replicate the manufacturing process without adequate tungsten supplies. A technical report from the WWII Weapons Testing Office in January 1945 stated, "The American projectile uses tungsten carbide penetrator of superior density and hardness to our own Panzergranit 40. The manufacturing quality suggests industrial capacity and tungsten availability we cannot match. Development of countermeasures is not feasible with available resources. Recommendation: avoid engagements where enemy may employ this ammunition." This recommendation to avoid combat represented complete admission of defeat. German armor, which had dominated battlefields from Poland to the outskirts of Moscow, was now advised to avoid fighting because American ammunition had negated armor advantages. The psychological and strategic implications were profound. If German tanks couldn't fight American tanks with confidence of survival, then Germany's armored forces had lost their primary function. They became defensive weapons to be used from concealment rather than offensive weapons to be used with maneuver. The Battle of the Bulge provided a final test of German armor against HVAP-equipped American forces under conditions that should have favored Germany. The Ardennes offensive concentrated Germany's remaining armor strength, approximately 1,400 tanks and assault guns, for a desperate attempt to split Allied forces. German planners assumed that winter weather would ground Allied aircraft, negating American air superiority. They assumed surprise would catch American forces unprepared. They assumed their armor superiority would dominate the initial battles before American reinforcements arrived. All three assumptions proved partially correct, yet the offensive failed, partly because HVAP ammunition undermined German armor effectiveness, even in conditions favorable to Germany. At St. Vith, American tank destroyers using HVAP held off repeated attacks by the 1st SS Panzer Division, destroying 27 Panthers and 8 Tigers over 3 days of fighting. Near Bastogne, the 10th Armored Division's Combat Command B, equipped with HVAP, destroyed 45 German tanks while losing 19 of their own, a kill ratio that would have been impossible with standard ammunition. Lieutenant Colonel Clifford Templeton, commanding a tank destroyer battalion at St. Vith, filed an after-action report that summarized HVAP's effectiveness. "We engaged German armor at ranges from 800 to 1,500 meters throughout the battle. HVAP rounds achieved penetration in 87% of hits against Panther frontal armor and 94% of hits against Panzer IV frontal armor. We destroyed 27 Panthers, 11 Panzer IVs and 3 Tigers, losing 9 M10 tank destroyers, 3 to German tank fire, 6 to infantry anti-tank weapons. Without HVAP, we would have been overwhelmed." German commanders analyzing the Bulge offensive's failure cited multiple factors: logistics, fuel shortages, weather clearing allowing air attacks, and American defensive determination. But captured documents revealed that HVAP ammunition featured prominently in tactical assessments. General der Panzertruppen Heinrich von Lüttwitz, commanding 47 Panzer Corps, wrote in his final report, "American anti-tank capabilities exceeded our estimates. Their standard 76mm tank gun, previously inadequate against our armor, has been rendered effective through improved ammunition. Panthers and Tigers were destroyed at ranges we considered safe. This forced our tanks to close rapidly, disrupting attack coordination and increasing vulnerability to artillery and air attack. The strategic implications of HVAP extended beyond individual battles. American possession of tungsten ammunition that could kill German heavy tanks fundamentally altered the armor balance on the Western Front. German advantages in tank quality became irrelevant when American tanks could destroy Panthers and Tigers from positions of concealment at ranges where German tanks couldn't return effective fire. The careful engineering that went into German armor design, the sloped plates, the thick mantlets, the carefully calculated angles, all became meaningless when tungsten penetrators punched through as if armor thickness didn't matter. This technological defeat mirrored Germany's broader strategic situation. German engineering excellence, which had produced superior individual weapons systems, couldn't overcome Allied material superiority backed by industrial capacity and strategic resources. The Panther was arguably the best medium tank of World War II, but Germany produced 6,000 Panthers while America produced 49,000 Shermans. The Tiger was nearly invulnerable to most Allied weapons, but Germany produced 1,350 Tigers while America produced enough tungsten ammunition to negate that invulnerability. Superior engineering couldn't defeat superior resources. The post-war interrogations of German tank commanders provided the most comprehensive assessment of HVAP's impact. These officers, removed from combat and no longer constrained by propaganda requirements, spoke candidly about how American ammunition had transformed armored warfare. General der Panzertruppen Heinz Guderian, the father of German armored doctrine, when asked what Allied innovation had surprised him most, responded, "The American development of hypervelocity ammunition. We knew they had tungsten resources, but we assumed they would use it for larger guns. Instead, they made standard guns deadly through ammunition improvement. This was brilliant engineering that we couldn't counter." Oberst Hans von Luck, who had commanded armored units from 1941 through 1945, provided more emotional testimony. "The worst moment wasn't losing battles. It was watching our men lose faith in their equipment. Tank crews who had fought bravely for years became cautious and fearful because they knew American guns could kill them at ranges they thought safe. HVAP destroyed our morale as effectively as it destroyed our tanks. We had built our entire doctrine around armor superiority, and the Americans took it away with better ammunition." The statistical summary of HVAP effectiveness compiled from American and German records revealed the ammunition's decisive impact. In engagements where HVAP was available and used, American kill ratios improved from approximately 1.2 to 1 to 4.5 to 1 against German armor. Penetration rates at 1,200 meters improved from 15% with standard AP to 89% with HVAP. German tank loss rates in the final 6 months of the war were 40% higher in areas where HVAP-equipped American units operated compared to areas where only standard ammunition was available. The human cost of HVAP's effectiveness was measured in German casualties. Approximately 3,200 German tanks were destroyed by HVAP ammunition between August 1944 and May 1945, according to post-war analysis of combat records. Each destroyed tank typically resulted in 2 crew fatalities and 3 wounded. HVAP therefore directly caused approximately 6,400 German deaths and 9,600 wounded, numbers that don't include the indirect casualties from battles where HVAP inflicted losses contributed to German defeat. Individual tank aces' careers illustrated how HVAP changed the armor battle. Lafayette Poole, the American tanker mentioned earlier, achieved ace status, 5 or more tank kills, using HVAP ammunition. He would never have achieved this status with standard ammunition. as his first several encounters with German armor using standard AP had resulted in his shots bouncing off, while German return fire forced him to retreat. Only after receiving HVAP did his effectiveness multiply. His story was repeated across hundreds of American tank crews whose competence was unlocked by ammunition that let them compete with superior German armor. The German tanker perspective showed the opposite transformation. Michael Wittmann, Germany's highest-scoring tank ace with 138 kills, died in August 1944 when his Tiger was destroyed by concentrated fire that included HVAP rounds. His death, whether directly caused by HVAP or not, symbolized the end of German armor dominance. Wittmann had survived dozens of engagements because his Tiger's armor protected him. By August 1944, that protection was no longer reliable. Even Germany's best tanker in their best tank could be killed by ammunition that made armor thickness irrelevant. The technological legacy of HVAP extended beyond World War II. The principle of sub-caliber penetrators launched at high velocity became the foundation of modern armor-piercing ammunition. Today's tank ammunition, armor-piercing fin-stabilized discarding sabot, or a PFSDS, uses the same concept HVAP pioneered tungsten or depleted uranium penetrators in discarding sabots, achieving velocities exceeding 5,000 feet per second. The M93 HVAP round, developed in desperation to counter German armor superiority, established principles that govern anti-tank warfare 70 years later. The strategic lesson of HVAP was equally enduring. Material science and industrial capacity can overcome tactical disadvantages. The United States couldn't match German tank engineering in the time available, so American engineers solved the armor penetration problem through ammunition improvement. This approach, leveraging American strengths in chemistry, metallurgy, and industrial production, achieved victory more effectively than attempting to match German strengths in armor design. The lesson applied broadly. Fight the war you can win, not the war your enemy wants. For German tank crews who faced HVAP in the war's final months, the experience represented complete reversal of fortunes. They had begun the war in tanks that dominated their opponents, Panzer IIIs and IVs that outclassed Polish and French armor. They had progressed to Panthers and Tigers that seemed invincible against Soviet and Western Allied tanks. Then, suddenly, their armor advantage vanished. The invincibility they had relied upon became illusion, shattered by tungsten penetrators traveling at impossible velocities. Unteroffizier Carl Schmidt, who survived the war after serving in Panther and Tiger units, summarized the experience in a 1979 interview. "We went from hunters to hunted. In 1943, we feared nothing. Our armor was so thick that Russian and American guns couldn't hurt us at normal combat ranges. We maneuvered aggressively because we knew we were protected. Then in late 1944, everything changed. American guns that had been harmless suddenly became deadly. Our thick armor meant nothing. We started dying at ranges where we thought we were safe. The fear was overwhelming because we couldn't see the difference between normal Shermans and those carrying the special ammunition. Every engagement might be our last, and there was nothing we could do to protect ourselves except avoid fighting." The psychological destruction HVAP inflicted on German tank crews mirrored the physical destruction it inflicted on German tanks. Men who had been confident warriors became cautious survivors. Units that had maneuvered aggressively became defensive and passive. The spirit that had animated the Panzer Arm since its creation was extinguished by the realization that material science had made courage and skill insufficient for survival. German tank crews in early 1945 knew they were fighting a losing war against an enemy whose industrial capacity could produce solutions to every German advantage. The final accounting of HVAP's impact came in the post-war assessments compiled by both American and German military historians. The U.S. Army's Operational Research Group concluded that HVAP ammunition had been one of the three most decisive tactical innovations of the war's final year, alongside proximity-fused artillery shells and improved tank infantry coordination. The German Bundeswehr's historical section, analyzing why German armor had failed in 1944 to 45, identified Allied ammunition superiority as a critical factor that German planning had failed to anticipate. The numbers told the story with brutal clarity. Total HVAP production exceeded 800,000 rounds by war's end. German tanks destroyed by HVAP numbered approximately 3,200, representing 23% of all German armor losses on the Western Front after August 1944. American tank effectiveness, measured in kill ratios, improved 370% in units equipped with HVAP compared to those using only standard ammunition. German tank crew casualties increased 40% in areas where HVAP was deployed. These statistics represented not just material losses, but the systematic destruction of German armor effectiveness through American metallurgical innovation backed by industrial capacity. The broader strategic context made HVAP's impact even more significant. By 1944, Germany faced critical shortages in every strategic resource except human soldiers and defensive determination. Fuel shortages grounded aircraft and immobilized armor. Ammunition shortages restricted artillery fire. Food shortages weakened civilian morale. In this context of cascading scarcity, Germany's one remaining advantage was the qualitative superiority of their heavy tanks. Panthers and Tigers couldn't win the war, but they might slow defeat enough for political developments to save Germany from unconditional surrender. HVAP eliminated even this limited hope. When American tungsten ammunition negated German armor superiority, Germany's last tactical advantage evaporated. The Panthers and Tigers that should have held defensive positions for weeks fell to HVAP-equipped Shermans in days. The armor reserves that should have counterattacked Allied breakthroughs were destroyed at ranges where German crews thought they were safe. Germany's final gamble, the Bulge offensive, failed partly because HVAP let inferior American tanks defeat superior German armor through ammunition advantage. On April 30, 1945, as the Third Reich collapsed, the final report from the Waffenamt Weapons Office included a section on Allied ammunition developments. The text, written by officers who knew Germany's defeat was imminent, provided candid assessment. The American hypervelocity armor-piercing ammunition represents a technological achievement we could not match with available resources. Their tungsten supply, industrial capacity, and metallurgical expertise combined to produce ammunition that rendered our armor advantages meaningless. This innovation, more than any single American weapon system, contributed to our defeat in armored warfare. We could not defend against ammunition that made armor thickness irrelevant. This admission, buried in files captured by American forces, stood as German armor's epitaph. The Panzer arm that had revolutionized warfare in Poland, France, and Russia had been defeated not by superior enemy tanks, but by superior enemy ammunition. The Tigers and Panthers that had seemed invincible were destroyed by Shermans firing tungsten penetrators that punched through armor as if thickness and angle didn't matter. German engineering excellence had been overwhelmed by American material science backed by industrial capacity and strategic resources. The individual German tank commanders who survived the war carried memories of their encounters with HVAP like scars. They remembered the impossible penetrations, the deaths of friends who should have been protected by armor, the fear that replaced confidence, the knowledge that their advantages had been negated by enemy innovation they couldn't counter. These memories shaped their understanding of what had gone wrong. Germany had lost, not because German soldiers weren't brave or skilled, but because German industry couldn't match Allied resources, and German strategy had underestimated Allied innovation. Ernst Bachmann, whose Burning Panther began this story, survived the war and lived until 2010. In interviews, he consistently identified HVAP ammunition as the weapon that destroyed German armor morale. We had trusted our armor absolutely. That trust was the foundation of our effectiveness. When HVAP came along and made our armor worthless, we lost more than protection. We lost psychological security. Every battle became terror rather than combat. I survived because of luck, not armor. The Americans had solved the armor problem, and we had no answer. The legacy of HVAP extended beyond World War II into the Cold War and modern era. The Soviet Union, examining captured German armor destroyed by HVAP, accelerated their own development of sub-caliber ammunition. By 1950, Soviet tanks carried APDS ammunition based on HVAP principles. When American and Soviet tanks faced each other in proxy wars from Korea to the Middle East, both sides used tungsten or depleted uranium penetrators in discarding sabots, direct descendants of the M93 HVP that had shattered German armor superiority in 1944. The fundamental lesson HVAP taught remained relevant into the 21st century. Armor protection is an arms race between penetrator and plate. Every improvement in armor thickness or composition can be countered by improvements in projectile velocity or penetrator density. The M93 HVAP demonstrated this principle decisively. German engineers had designed Panthers and Tigers with armor they believed couldn't be penetrated by existing Allied guns. American engineers didn't build larger guns. They built better ammunition. This approach, solving the problem through innovation rather than escalation, characterized American technical superiority throughout the war. In the end, when Germany faced HVAP rounds and realized their Tiger armor meant nothing, they were learning the hardest lesson of industrial warfare. Material advantages are temporary. Innovation can overcome any defensive measure. Strategic resources matter more than tactical excellence. The tungsten cores that punched through German armor at 3,400 feet per second carried a message more devastating than their kinetic energy. German advantages could be negated, German defenses could be overcome, and German defeat was inevitable once American industry turned its full attention to solving tactical problems. The story of HVAP is ultimately the story of how superior resources defeat superior engineering. The Panthers and Tigers were arguably better tanks than the Sherman. German crews were often more experienced than American crews. German doctrine was sophisticated and battle-tested, but none of this mattered when American metallurgists produced tungsten carbide penetrators that made armor thickness irrelevant. The Sherman, armed with HVAP, became deadly to German heavy tanks at ranges where German doctrine said Americans couldn't hurt them. This transformation, achieved through ammunition improvement rather than tank redesign, represented American industrial warfare at its most effective. The final image that captures HVAP's impact is simple but profound. A Tiger I tank, 56 tons of German engineering excellence, destroyed by a single 76mm HVAP round that weighed 15.4 pounds. The enormous disparity between the weapon and the target it destroyed represented the essence of technological warfare. Size, weight, and armor thickness meant nothing against a projectile traveling at the right velocity with the right material composition. The Tiger's crew died because American engineers understood tungsten carbide properties better than German engineers understood armor protection. That knowledge gap, measured in milliseconds of penetration and millimeters of tungsten, decided the armor war. When German tank commanders stood beside their burning Tigers and Panthers, watching tungsten-inflicted fires consume vehicles that should have been invincible, they witnessed the death of German armor superiority. They witnessed the triumph of American material science over German engineering. They witnessed the inevitable outcome when industrial capacity meets tactical excellence and overwhelms it through innovation. The HVAP rounds that destroyed their tanks destroyed something more fundamental: the belief that German quality could overcome Allied quantity. That belief died in flames fueled by tungsten penetrators, and with it died German hopes of avoiding total defeat.